All right, so today we'll finish up with the last two operations we're going to use trig form of complex numbers for. And that's going to be to raise complex numbers to powers. And we're going to use a theorem called Moivre's theorem. And then we're also going to take roots of complex numbers. All right, so let's pretend that this is our number in trig form. Okay, if we were doing an actual problem, r and theta would be numbers, not variables. But I want to take this and square it. Okay, we're going to square it just the way you would think. We're going to multiply it out the long way, and hopefully you'll see a pattern. So what does it mean? Like if I write z here, then I put z squared below it. What does z squared mean? Like if you wanted to write z squared without a 2 up high, z times z. So I'm going to take z and put times z. So I'm going to write it twice. I'll just write it. So I have r cosine theta plus I sine theta, that's z. And I'm going to multiply it by itself. Z squared. R cosine theta plus I sine theta. All right, now one thing I could do is we have 4 factors here. 1, 2, 3, 4. Factors are separated by multiplication signs. So we have r times what's in the parentheses, times another r, times what's in the other parentheses. So first thing I can do is I can reorder, okay, when I multiply. Like if you have 4 things multiplied together, does the order matter that you do them in? Like, if this was 1 times 2 times 3 times 4, is that the same as 2 times 1 times 3 times 4? Yeah, the order you multiply numbers in doesn't matter. So there's a couple here that are similar I could multiply. I could multiply the first term and the third term and simplify that first. Okay. What's the first factor times the third factor? R squared. So I've got that. Okay. And that's going to leave me with everything else. Okay, so I can write it again. If you don't want to write this step, you don't have to. You can write just the next step. But I'm going to write down what I have now. So I have r squared. And then I've got cosine theta, I sine theta. Got to keep the parentheses around that. And then another cosine theta, I sine theta.
Isn't that just cosine theta plus I sine theta squared, right?
Yep. How would you do that out though? Like if we had something like, x plus y times x plus y. You could write x plus y squared, or if you do it out, what's the?
You FOIL, right?
FOIL it, yeah. So we're just going to multiply everything out, see what we get. So we've got cosine times cosine, which is what? Cosine squared. We have cosine times I sine theta, and then cosine times I sine theta again. So we have 2 of those. 2 of the cosine I sine theta. And I'm going to write it. How am I going to write it? I'll write it like that. It doesn't matter the order you really put the 2, the I, the sine, and the cosine in, as long as you have cosine times I times sine, and taking into account you have 2 of them. Okay. And then the last step, we have I sine times I sine. Well, let's start with I times I. It's I times I. I squared, which is what number? So we have a negative. So I'm just going to put minus. Okay. And then I have sine times sine. Sine squared. Okay, now I'm going to take what I what I have there, I'm going to regroup it a little bit. I'm just going to change. I'm going to change the order and see if you notice something. I'm going to put cosine squared minus sine squared right next to each other. And then I'm going to put plus. And the last thing I have is 2 sine cosine. And that's imaginary. So this and that is something special. Does anybody recognize what cosine squared minus sine squared is? Okay, and we did this. I'm trying to think of the section. Back, I think it was section 7. No, it wasn't 7.4. It was 7.5. Yep. We did this back in section 7.5. Okay? Yes, these, well, no, that's not a Pythagorean identity. If it was sine squared plus cosine squared, it's a Pythagorean identity. But this is an identity. It's a trig identity. Does anybody remember what cosine squared minus sine squared is? So look back at your notes for section 7.5. It's when we did the sum and difference identities. It's not a sum or difference, but we also did double angle identities and half angle. So it's something to do with one of those. Yeah? These are both double angle identities, yes. What's cosine squared minus sine squared? It's cosine 2 theta. Okay. How about the other one? What's 2 sine cosine?
Sine 2 theta.
That's sine 2 theta. And just so there's no confusion, I'm going to put the I in front because that's where we normally put it. So this is what you get when you square this. So I want you to look at this box and how we got to this box, just comparing what you started with in the final answer. Did anybody see a pattern how we got from one box to the other? What did we really end up doing? Okay, so we doubled the angle, right? Where did this 2 come from? Why do you think it turned out to be a 2 and not a 3 or a 4 or something else? Because we squared. Squaring is a 2. So we ended up multiplying the angle by the exponent. And then what about the radius? We just squared it. And that 2 from there came from squaring. So let's see if we can write down what you think z cubed would be without doing it all out. R cubed.
Cosine 3 theta
Yep.
plus I sine theta.
Yeah. So what we just used, but we don't really know the name of it yet, that is De Moivre's theorem. If you want to raise a complex number to a power, you raise the radius to the power, and you multiply the angle by the power. Now, for squaring something, De Moivre's theorem doesn't really save you too much time. But let's say you wanted to take and do this to the 4th power. Okay? In trig form, you'd have to rewrite this in trig form first. And then you take the radius to the 4th power and multiply your angle by 4. If you didn't want to use trig form, the way I just explained it, this is what you'd have to do. 3 plus 2i, 4 4 times. This is what you would have to do in standard form. It's not hard, but it is a lot of calculations to make, and you're probably going to make a mistake somewhere. Because you've got to FOIL the first 2 together, get your answer, take that answer, and then FOIL it with the next one, simplify it, get that answer, and FOIL it with the next one. It's still doable. But the point is, what if you had something just not doable? If you wanted to raise something to the 45th power, you can't multiply it out 45 times. It's going to... You do it in your head? And you probably, even if you could do it, you'd probably make a mistake somewhere. But in trig form, all you'd have to do is take your radius, raise it to the 45th power, just type that in, take your angle, multiply by 45, and you'd be done. Okay, so trig form is very fast to raise numbers to powers.
Can you go back to that thing real quick? Is that in the bottom? So is that 20 or is that 2 theta and then
2 theta.
Oh, okay, all right. So theta is the angle. Right?
Theta is the angle. So if you've got a number you want to raise to a power, okay, let's say you want to raise something to the nth power. Take the radius, raise it to the nth power, take the angle, and multiply it by the n. Okay, and we're also only going to be working with integer powers. In fact, we're not even, we're just going to do integer powers. 2, 3, 5, 6, things like that. Okay, but this relies on you knowing how to get a number in trig form. You have to know how do you get r and how do you get theta. That's what we did yesterday. And again, this is called de Moivre's theorem. That's how you say it.
Is it French?
I think so. Okay, so any questions on the theorem? We'll try an example now. Okay, now keep in mind, you can always simplify answers. Like, sometimes when you multiply an angle by a number, it can get pretty big. So let's say your angle was like 80, and you had raised this to the 10th power. So you'd have an angle of 800 degrees. But what can you do to that angle to make it smaller? Nope, we can't divide by 360. Subtract. You can subtract 360. So, in that case, it comes out the same. But if you get an angle that's bigger than 360 or smaller than 0, you generally want to get your answer between 0 and 360.
So if it's 800, you just subtract 360, right? But that would be that still wouldn't be less than 360.
That is less than 360, 80.
So you just have to do it again until.
Yeah, you got to subtract 360 maybe twice. Okay, so if you get a really big angle, like 490, on the test I would look for you to write that as 130. Okay, so keep that in mind. All right, what's wrong with this to do de Moivre's theorem right away? Yeah, it's not in trig form. This is standard form. If you're going to do it in standard form, you've got to write 1 plus root 3i, 3 sets of parentheses, and then FOIL everything out and combine all the like terms. Okay, on the test, I'm probably going to give you one that you can't do in standard form. It would be unreasonable, like to the 7th or 8th power. But if you do it in trig form, it'll be very easy. Okay, so first thing I have to do is write this in trig form. Okay, and that's going to be the longest part of the whole problem, just getting this in trig form. So what do I have to know first? What quadrant? So that'll help me to find theta. So right 1, up square root of 3. I'm in quadrant 1. What's my formula for theta in quadrant 1? Inverse tangent of y. In this case, it's just over 1. Okay, so the inverse tangent of the square root of 3, let's do it in degrees because, as I said, anytime you have a square root of 3 or square root of 2 in the argument, it usually comes out nice. So inverse tangent of second square root of 3. Yeah, let's try second square root 3. We get, I thought I changed degrees.
Yeah, I thought you were saying you had done radians.
60. Okay, so my angle is 60. And now my radius. Okay, somebody tell me my formula to find the radius.
It's all squared.
What's that?
It's supposed to be r squared.
Yep.
You have to do, it's 1.
Well, I'm finding the radius, so I'm doing the Pythagorean theorem.
It's 1 squared plus 3 squared, or square root of 3 squared, right?
1 squared plus the square root of 3 squared. Yep.
And that just means 1 plus 3, which is 4.
Which is 4. So my radius squared is 4. What's my radius? 2. Okay, so now I can finally write it in trig form, and then I can cube it, and that part will be super easy. So r cosine, what was the angle, 60?
Yeah. Yes.
60 plus I sine 60. And now you're going to take all of this and cube it.
So it's,
So what do you do with 2?
you cube it.
Cube it. I'll write that down, and then we'll do it separate. So 2 cubed.
And then cosine time, it's 60 times 3, right?
Take your angle and multiply it by your power.
180 degrees. Right?
180 degrees. Questions on that?
Wait, so you just took 16.
So this is trig form.
Yeah.
Questions on how we got to trig form? No? Okay. So I cubed the 2
Yep.
because I'm cubing, and I multiplied the angle by 3 because I'm cubing. So you take the radius, raise it to the power, take the angle, multiply it by the power.
So it'd be 8 cosine.
Yeah, we could simplify that to 8. Cosine 180, I sine 180. Now that is your answer in trig form. And if they say to leave it in trig form, you're done.
Well, how would you convert that to standard form?
So we just type in cosine of 180 on a calculator and see what we get. Cosine of 180 is -1. Plus, type in sine of 180, 0. And what's something times 0?
0.
0.
So just -1.
Well, it's 8 times what's in parentheses.
It's -8.
It's -8.
You're supposed to solve the homework.
You're supposed to what?
Like solve the homework or just
Like what I just did?
Yeah.
They might ask you when the angle comes out like this, they might say to simplify it. On the test, it'll be very clear whether or not you need to stop with that box or keep going. A lot of problems today, we're going to stop with what's in the box. But because this is a quadrantal angle, I know the arguments, 0, 90, 180, 270, you're going to get answers of all zeros and ones.
So if it's on the axis, technically then.
Yeah, if it's on an axis, they'll probably have you simplify it like I just did, because you're going to get a very nice answer. So if you take and cube that number, 1 plus root 3i, what you get is -8. Okay? In standard form, -8 plus 0i, there's no imaginary part. So cubing that number caused the imaginary part to disappear. You don't notice that when you write it like this, unless in your head you know the sign of 180 is 0, and 0 times anything wipes that part out. And so any questions on how we got trig form? Or we simplified it a little further to just the number -8. All right, let's try this one. I'm not sure why I wrote my fraction horizontal, but usually I write it like that. So now we're doing one that's just unreasonable to try to do by hand. You're raising to an 8th power. So let's find our angle first. What quadrant am I in?
Quadrant 2.
Yeah, quadrant 2. And what do you notice about the amount that I'm going left and then the amount that I go up?
They're equal.
They're exactly the same, right? Well, negative just means you went left root 2 over 2 and then up root 2 over 2. So if this amount is the same as this amount, that gives us a hint at how big that angle is right there.
45.
That's a 45, 45, 90 triangle without even using inverse tangent. Now, what's that angle to right there? That's what would give us on the calculator if we typed it in.
145? Or no? 135.
Yeah, it's a 45-degree angle in the second quadrant. Okay, 45-degree angle in quadrant 2 is 135. If that confuses you doing it that way, and the only reason I could do it is because it worked out really special, you can type inverse tangent of y over x on the calculator, and you'll be typing inverse tangent of -1. You'll get -45. And then in quadrant 2, what do you always have to add to the angle? You'd have to add the 180, and when you do that, you'd get what I wrote right there. Okay. Now my radius. What's x in this case?
-2, the square root 2 over 2.
Negative root 2 over 2. And what do we have to do with it? Square it, because we're doing Pythagorean theorem. What about y? Yeah, so really when you square both of these, they're going to come out the same because that negative is going to disappear. So what do you get when you square the square root of 2? 2. And then when you square 2, 4. And then when you square the positive root of 2, it's still 2. Square 2 again, we get 4. So what's my radius squared? 1. So what's my radius? 1. Whenever the radius is 1, you really don't need to write it. Because it's like putting a 1 on the outside to distribute of what you're going to put inside parentheses. So if the radius is 1, you don't have to write it.
So is it like when both sides are equal to each other, like both the x and the y, is it always going to come out to like a 1? Like a simple number like that?
No. Nope.
Doesn't happen in the last problem you did, it was just, they're both 1.
Yeah, so like if you had like -2 plus 2i, like they're both the same number, this radius would not come out to 1.
Oh, okay.
It would come out to square root of 4, the square root of 8.
Oh, okay.
The radius in this problem would be square root of 8. So, yeah. Okay, so any questions on how we got the angle or the radius, which we don't really need?
Yeah, I'm still confused on how you get that mean 30 minus 30.
So because it's an isosceles triangle, right? Because this side is root 2 over 2. This side is root 2 over 2. The only way I can have an isosceles triangle, if that's a 90, is these both have to be 45s. Otherwise, it wouldn't add up to 180. So if that's a 45 right here, and this part is a 90, my question is, how big is this angle? Well, this part is 90, and then 45 more in the second quadrant. Or you can just do inverse tangent of y over x, and you'll get the same plus 180, because you're in quadrant 2. And you'll get 135. Right, now, what power am I raising this to? 8th power. So as I said earlier, the 1 doesn't really matter. What's 1 to the 8th power? It's just going to stay as 1. And now, what do I do with the 135? Multiply by 8. So it's 1,080. But that's a pretty big angle. So what can I do to make that angle smaller? I can minus 360. How about now? Do it again. I'll do it one more time, yeah. So the angle turns out to be 0. Okay? So cosine 0 plus I sine 0. Is that a quadrantal angle, 0? Yeah, it's on an axis. So that's 1. If we simplify it, we're going to get a very nice answer. If I take the cosine of 0, I just got 1. And if I take the sine of 0, I get 0. So sine of 0 is 0. What's 0 times I? 0. So I'm left with a 1 in the parentheses. And I'm left with just 1. So if you take this number and raise it to the 8th power, you just get the number 1. Any questions on that one? Yeah. So let's go back and look at example 1. Okay, what did I do in example 1 here? What operation? What's the problem asking me to do?
Raise it to a power.
What power specifically?
3.
3. Yeah, I cubed something. So if you take this and cube it, you get that. All right? So let me ask you about something even simpler. Let's take a regular number just like 2, and let's cube it. What do you get? 8. So if you cube 2, you get 8. What does that mean about the number 2? It's the what of 8? It's the cube root. If you cube it and you get 8, then 2 must be the cube root of 8. Okay? Same thing like if you did this. What's 3 squared? 9. So that means 3 is the what of 9? It's the square root of 9. Does that idea make sense? Okay, so let's look at this one. See if I can put it on the screen at the same time. Not quite. So if you cube this, you get -8. So what does that mean -8 is compared to that number I just underlined? It's the cube root. Now, when you find a cube root, there's 3 answers. Just like when you find a square root, there's 2 answers. This is one of the cube roots of the number I just underlined. Okay? So, that's what I just said. So if you take the cube root of the example 1, you would get -8. How do we know that? Because we cubed that and got that. Just like if I said to you, prove to me that 3 is the square root of 9. Well, if you take 3 and square it, and you get 9, then that means 3 is the square root of 9. That's how you could check it. Okay, so when we cubed this, we got that. So that means this is the cube root of that, or at least one of the cube roots. Okay, that idea is a little weird at first, but hopefully it makes more sense when I just used non-imaginary numbers like 3 squared and 2 cubed. Okay, any questions on that idea? That's kind of where we're heading now. So the last thing we're going to look at is roots. All right, so I'm going to write down how to find nth roots. It's a lot easier to go through an example than it is to describe how to do it without numbers. So I will describe how to do it, like I'll give you the steps in general, but it's going to make a lot more sense when we just use actual numbers. So the goal is you have to satisfy this equation. That's how you find an nth root. Like, let's say I did this. Picked Very simple numbers. I let z be 3, I let n be 2. If you want to calculate, actually no, I would do it like this. Other way around. Like that. Okay, if you want to calculate a square root, you have to solve that equation. If you can solve it, you can tell me the square root of the number 9.
Use log, right?
No, you just take the square root of both sides. That's it. To solve that equation. So these are the kind of equations we're going to be solving. You're going to have a variable down here, you're going to have a number here that you know, and you're going to have a number here that you know. And to solve it, you're going to have to, that's what I'm about to explain, how to solve it. Okay? But that's the idea. So if you had an equation like that, you'd be solving for a square root. If you had an equation like this, you couldn't take a square root of it to solve it. What would you have to do? You'd have to do a cube root. Okay? That's how you find an nth root. Okay? Solving an equation that starts out looking just like that.
Mr. Hager, isn't that kind of like how a log would be set up, right? So it'd be like the log of 3, 9 equals x, right? So that's what you're trying to find.
Yeah, we've done stuff with logs before. We won't have to here, but yeah, we've done problems similar to that with logs, rewriting it, yeah. Yep. So all that this says is z and a are complex numbers. So if you want to write it that way instead of that abbreviation, that's fine. Both z and a are complex numbers, because we're working with complex numbers. Okay, and the only way to really do this and make it somewhat simple is to rewrite the equation we need to solve in trig form. Okay, so I'm going to show you how we do that. So, A, we're going to write it in trig form. It's going to have a radius and an angle. When we do an actual problem, we will know some of these numbers. Okay, but for now, we don't know any of them, so I just have to use r's and thetas. And z is also going to be a number in trig form. Again, I don't know what z is, so I just have to use r's and thetas. But when we get to an actual problem, we will have numbers we can fill in for this. That's what will make it a little simpler when we can actually put numbers in it. Okay, so all I'm going to do is I'm going to take what I have for A, what I just underlined, and I'm going to fill it in for A. I'm going to take what I underlined right there, and I'm going to fill that in for Z. So I'm going to rewrite this exact equation, just putting those two things in. So it's going to turn it into trig form. So it'll be R2 cosine theta 2, I sine theta 2 to the n. Right, that's Z. And on the other side, I'm not going to put A. I'm going to write R1 cosine theta 1 plus I sine theta 1. Now, the next step, on this side, focus on what I just put a box around. I can do out what I just had a box around with de Moivre's theorem. How would I raise all of this to the nth power? What would I have to do with the radius first? You'd raise the radius to the nth power. Yep. And what would you do with the angle and the n? You would times them. So it's going to be n times the angle. When we do an actual problem, you're going to have numbers in there. But for now, I don't have numbers, so I just have to write it like that. N times the angle. So raise your radius to the power, multiply your angle by the power. And it's exactly the same thing, right, with the sign as well. On the other side, I didn't change anything. I just copied it down. Okay, so now when we look at that, we want what's on the left and what's on the right to match each other. Well, what's on the left has a radius. What's on the right has a radius. So you want the blue box on the left to match the blue box on the right. Okay, those two things have to match. So write that down. The box on the left has to match the box on the right. That's how you're going to solve for your radius in the final answer, just by setting box 1 equal to box 2. Now, in order for these equate what's on the left to match what's on the right, not only do the radii have to match, but what else has to match besides the radius? The angles. So this angle has to match this angle. We'll call that box 3 has to match box 4. Now, the only thing that's a little tricky with the angle is it doesn't necessarily just have to match the angle. It could match anything that's coterminal with it. Okay? For example, this is exactly the same as that. All I did was add 360. It's the same as that, which is also the same as that. All I'm doing is adding 360 over and over, but they are different numbers, so they can give me different answers. So with this part, the angles have to match each other, or they can match anything if you did it in degrees, which I'll do some in degrees. Anything coterminal with the angle. Coterminal means the angle when you add or subtract 360 from it. Okay, so it's really pretty confusing when you just look at it with letters, but all of this is going to turn into numbers when we do a problem. Okay, so it's going to be just, it's all arithmetic.
Is that a K?
Yeah. So that just represents adding multiples of 360. 360, 720, things, and so on. Okay, so this is definitely the hardest thing we look at this week. So when you do roots in trig form, you're always going to get a single answer for the radius. You're going to get one answer. R is 3. But when you find the angle, you might get multiple answers. In fact, you get as many answers as you're taking the root. I think I wrote that. So an nth root has n answers. So that means a square root would have how many answers? 2. A cube root would have 3. A fifth root would have 5. Okay, on the test, I don't think I go much above a fourth, probably a fourth root. And how you find the answers all has to do with k. If you have 2 answers, the way you would find them is you would plug in a 0 for k, and you would plug in a 1 for k. 0, 1. There's your 2 answers. If you had 3 answers, you would plug in a 0 for k, a 1 for k, and a 2 for k. 0, 1, 2. There's your 3 answers. If you were finding 4 answers, you would plug in, what would you plug in for k if you were finding 4 answers?
0.
0. Yep. 1, 2, 3. There's your 4 answers. So notice you're always 1 less than the root. 4th root, 0, 1, 2, 3. There's your 4 answers, because you're starting at 0. All right, so we'll just spend the rest of the class trying some examples of this, okay? Because it's definitely the kind of thing you got to try a few examples, and then it will make more sense after we do a few. One thing special the book uses, I'm not going to use this word because I don't want to confuse you, but if they ever ask you to find the roots of 1, there's actually a special term for that. It's called finding the roots of unity. So any other number, I just have to say the number. Find the cube roots of 2. Find the square root of 7. Find the fifth roots of 9. Well, if you're working with the number 1, a term you can use is find the square root of unity. Okay, I probably won't say it because I'll just say find the square root of 1. But it means the same thing. Okay, so don't be overly concerned with that. If you see the word unity in the book, just cross it out if it confuses you. Well, don't really cross it out in the book. But just in your mind, cross it out and put a 1 there. Okay? Pretend that it says 1. That's all. All right, so let's try this one. As far as graphing, don't worry about the graph. When you graph your answers, it turns out they're all nicely spaced, but I just want to find them. That's good enough. So we're going to find the fourth roots of unity. Okay? And the way I would word this on the test, I'll just put a 1 there. So find the fourth roots of 1. Okay, so that's the equation you have to set up. This is the root you're finding. That's what you're finding the root of. Okay, so if you said to me, find the sixth root of 1, I would set up this equation. Exponent is the root. What goes on the other side is what you're finding the root of. Right. Now, we're going to write this whole equation in trig form. Okay, I want to get something that looks like this. Okay, on the left-hand side, that's what I'm solving for. I don't know what my radius is for z. I don't know what my angle is for z. So literally, I'm just going to write it like this. R cosine theta plus I sine theta. That's what's going to take the place of z. I have no idea what the radius or what the angle should be. That's what I'm solving for. But here's where we're going to get some numbers. On the other side, I have the number 1. That I can write in trig form. Okay? Let's convert the number 1 to trig form, just like we did in the homework last night. This is actually very easy to convert, because it's just a single number. When I graph the number 1, am I in a quadrant or on an axis? I'm on an axis. Think of it like this if you're confused because there's no imaginary part. Plus 0i. How do I graph that? What direction do I go? Right. 1 unit. So this one's going to be really easy. What's my radius from here to the origin? 1. I don't even need to use Pythagorean theorem because the imaginary part was a 0. If the imaginary part wasn't 0, then I'd use Pythagorean theorem to figure it out. And now my angle, normally I do inverse tangent of y over x.
0.
But I'm on the x-axis, so what's my angle?
0.
0. Okay. Goes up. So that's what goes on the other side. So the number 1 in trig form, or 1 plus 0i, is r cosine theta. Let's fill in 0. Plus I sine 0. Any questions on how I wrote the number 1 in trig form? Now, the left-hand side I can do out with de Moivre's theorem, just like I did, where did I do it? Right here. Okay, that's the next step. So what do I do with my radius and the power? Nope, we don't multiply the radius and the power. Radius gets raised to the power. And then what do we do with the angle and the power? Multiply them. And then what's on the other side? It's just going to be the same thing. Let's just see if I can just copy that down again. And now we're at the point where we have to set up our two equations. We need this to match what on the other side? 1. I'll do that in a second. And we need this to match 0. Or anything that's coterminal with it. So I need to put plus. We'll talk about that in a second. So let's start by setting the red circles equal. And now let's solve that equation and we'll know our radius in the final answer. What do you have to do to get rid of a fourth power? Take a fourth root. And let's do it on the calculator, even though we probably could do it in our head, just so you see how to type it in. To take a fourth root, we press 4. Go to math. And it's the 5th option down. And now type in your number. What are we taking the fourth root of? 1. And if you do that, what do you get? 1. So your final answer, that's your radius. And now let's set up our angle. 4 theta has to equal 0. Or, let's go back and look. The angle plus, it could be 2 pi or it could be 360. Depends on what units you used. We use degrees. So what would I put right here? 360 times k. Now, to write our final answer, we have to know how many answers there should be. What root are we doing? We're doing a fourth root. So how many answers should we get? 4. In every answer, you're going to have a radius. The radius is going to be exactly the same in every answer. And what I'm going to do is just copy this, or just write it a bunch of times. And I need to fill in my angle each time. Okay. To find my different answers, we could simplify this equation a little bit. What's 0 plus 360k? Just 0. Well, not 0, no. 360k. And remember, we want theta here. So how do you put the 4 on the other side? Divide. So we get theta equals, what's 360 divided by 4? 90k. There's your formula. And what values are you going to let k equal to get the 4 numbers to put in these 4 spots? 0, 1, 2, 3. So this one will be k equals 1, 2, 3, 4. So let's like, I'm sorry, I wrote that wrong. 0. You guys said it correct. Okay, let's start with 0. What's 90 times 0? 0, 0. First answer, done. Second answer, k equals 1. What's 90 times 1? 90, 90. Done. Third answer, k equals 2. What's 90 times 2? 80. Okay, third answer, and last answer, and then we're done. What's 90 times 3? 270. 270, 270. I kind of messed that up. Okay. And those are your 4 answers. Those answers you could simplify. Like if you type in the cosine of 0, you'd get a 1, and the sine of 0, you'd get 0. I'm not going to go through simplifying them because we've done that, but I'm just going to stop with trig form. Okay. Yep.
If I don't come into school tomorrow, it's probably because the homework killed me.
Homework killed you?
Yeah.
No, you'll be okay. Let's try this one. Let's find the cube roots of -8. So set up this equation first. Z to the root equals what you're taking the root of. Z, what root am I doing? Z to the root equals, what am I taking the root of? -8. Okay. first thing I do, replace z with r cosine theta, I sine theta, every time. R cosine theta, I sine theta. Always your first step. You don't have to change anything else on the left-hand side. On the right-hand side, what do I have to do with the number negative 8?
Put it on the grid,
Okay?
so it's to the left.
Yeah, this one doesn't have an imaginary part. It's just left 8. So what's the radius if you go left 8?
Or 8, because that's
Just 8. And what's the angle if you went left? 270 would be down. 180. Okay, so we got our angle, got our radius. You can put it all on the same line. I didn't have enough room. Now on the left-hand side, do de Moivre's theorem. What happens to the r? Raised to the third. What happens to theta? It gets multiplied by 3. And then you can copy down the right-hand side. We're not going to need it right now, but we will in the next step. Now we're at the point we set up our two equations. Okay. Who can tell me what on the left has to match what on the right? R to the third has to match 8, so we'll solve that right now. How do you solve r cubed equals 8? Take the cube root. I just showed you how to do it on the calculator, but does come out to a nice answer. 2. That's going to be your radius in every answer. And I know we don't have the angle yet, but let's set up our answers. How many answers are you going to have? 3, because you're doing a cube root. Cosine, 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 plus I sine, plus I sine, plus I sine. Okay, so I'll fill these in a second, and those are going to be my final answers right there. So I put r cubed equals 8, and then what else has to match what else? So 3 theta has to match 180, or how do I represent matching 180 or anything coterminal with it? Plus 360k. And now I don't want 3 theta, I want just theta. So divide by 3, make sure you divide everything by 3. What's 180 divided by 3? 60. And then 360 divided by 3? 120. Now, what 3 values are you going to let k equal? To get your 3 answers, 0, 1, and 2. Okay, let's start with 0. 120 times 0 plus 60? 60. Second answer, let k equal 1. What's 120 times 1 plus 60? 180. 180. 180. And last answer, 120 times 2? 240. What's 240 plus 60? 300. 300. And those are your answers. So once you learn how to do it, it's the same exact process every time. It's not a quick process, but it is the same process every single time. Okay? We can practice. I had a couple more. We're not going to have time to do them. But we can practice some more tomorrow when we go over the homework. Because tomorrow's lesson is very easy, so we can spend more time on the homework. Okay, so the homework is on 458. 3 through 5, 8 through 12, 26 to 28, and 35. Okay, don't get discouraged if you have trouble with the roots. It's not an easy process to learn at first. It definitely takes a little bit of practice. If the book says do it in radians, but it's easier for you to do it in degrees, do it in degrees. Okay, that's fine.